Hi, in this video we're asked to simplify. So first off, we've got this product a plus bi times a minus bi. So let's go ahead and we'll expand this and see what happens. Now in the last video we looked at how to expand this, and really this is a product of two binomials. But here we've got something in a form that you might have seen before. Well, we know that if we expand something in, let's say I have a product x plus y times x minus y. Here I'm multiplying conjugates, and this results in a difference of squares, x squared minus y squared. So here I've got a plus bi times a minus bi. These are conjugates. So I can expand this by saying that, well, this should be equal to a squared minus bi squared. And here, if I simplify this, well, I can't simplify a squared, but I know that if I do bi squared, this is the same thing as minus b squared times I squared. Well, I squared is just -1, so I'll have a squared minus -1 times b squared, which is the same thing as a squared plus b squared. So here, anytime I've got, these are called complex conjugates. Notice that I've got a plus bi times a minus bi, and a and b can be really any real numbers. Anytime I'm multiplying complex conjugates, I'll always have that the product results in the form a squared plus b squared. And that's because when I actually expand these conjugates, I get that this results in the difference of squares, a squared minus bi squared. When I squared I end up getting a negative number, so that results in a squared plus b squared. Actually, I get -1 when I squared I. And that's why it results in a squared plus b squared. So I can use that. Notice that anytime I multiply complex conjugates, I'll always get a number that's real. So that's a useful thing to know when dealing with complex numbers. Okay, in example B, it says to simplify a root b plus c root d times a root b minus c root d. So again, notice that I've got this in the form, or here I'm actually multiplying conjugate pairs. So I've got this in such that it's written as the product of x plus y times x minus y. So I can expand this because it's going to result, I can expand this quite easily because it's going to result in a difference of squares. We'll have a root b squared minus bracket c root d squared. Because when I multiply conjugates, it always results in a difference of squares. If I square a root b, I end up getting a squared b, because this square applies to both the factors in this in the brackets here. I have to square a, and then I square root b. If I square a, I get a squared. If I square root b, I just get b. And I can apply the same thing here. I've got, if I square c, I get c squared. If I square root d, that should just give me d. So notice that here I've got, inside of the brackets, I've got two values that are irrational. So I've got radicals. But when I multiply these mixed radicals, or the sum of these mixed radicals by its conjugate pair, I end up getting a number that is rational, because I don't have any radicals left in this product. So that's another useful thing. And in the next video, we're going to look at how to use conjugates to rationalize denominators.